So hello friends, now today I am going to discuss some basic statement like sparse matrices and graph. So today I discuss only the like some theoretical parts. So sparse matrices and graphs, we have already seen number of examples of the array and matrices. These are essential and entries in the many aspects of numerical computing. But just we have represented array with the numpy and array data structures, which is the heterogeneous representations, and that stores all the elements of the array that it represents. So now the number of the cases, there is a most efficient way to represent an object such as a vector, matrix, high dimensions array. Now however, some notable exceptions and matrices where the most of the elements are zeros, and such matrices are known as sparse matrices. Keep in your mind, notable exceptions are matrices where most of the elements are zeros. Such matrices are known as sparse matrices. They occur in the many applications for connections network. Okay, suddenly it might be dropped, and in the large algorithm equation systems that arises. So let's try to solve here. Means in future we will solve some partial equations. Also we will try the same type of problems. So matrices are dominated by elements that are zero. So it is insufficient to store all the zeros in the computer memory, and it is a more suitable to store only the non-zero value with the additional informations about their location. So for non-sparse matrices known as dense matrices, such as representations is a less efficient than storing all value consecutively in the memory, but for a large sparse matrices it can be a vastly superiors. So let's try. Just today I we are going to discuss. There are the several options for working with the sparse matrices uh, in a Pythons, but here we are the we mainly focus on the sparse matrices models in SciPy, SciPy.sparse. So which provide a feature rich and easy to use interfaces for representing sparse matrices and carrying out a linear algebra operations uh, on the on such objects. Another option is just PySparse, which provides the similar functionality for the very large scale problem, and PyTrilions and PETSc also, these are the package you can apply here. So see here. So here is the some parallel implementations. So let's see what should I do. Just first we need to the main modules that we work with these chapters, sparse modules in a SciPy library. So let's see the import. So first need to the import here, like here need to import. So first we will try to import and then to solve this problem. So let's see. Here import SciPy.sparse as sp, and next we can do just import SciPy sparse.linalg. But I will try to solve this problem. And second, we also needed the numpy library, so import numpy as a np, import matplotlib.pyplot as plt, and after that, because the last part of this chapter we use the network modules, which we import under the name nx. So import network x as a nx. So these are the basic. So sparse matrices in the SciPy and the others. So I try to the coordinates list dictionary of keys. I have already discussed so many things, so you can watch my previous video. Diagonal matrices, compressed sparse row. Okay, so all we have done already. So first we will create some variable like a value, rows, columns, and then we will use like a sp dot coordinate matrices. Okay, so I will discuss in the next class, don't worry, and step by step, and then functions for creating the sparse matrices, how to create a functions, and then we will discuss the structure of the sparse matrices with the non-zero elements only on the like a two diagonals closest to the main diagonals and the main diagonals itself. And we also try like a sparse matrices like a, this is associated with the tensor product spaces. So we try to solve this one. And next, just sparse linear algebra functions, so linear equation systems we try to solve. And we also compare like a performance comparisons between the sparse and dense methods to solve the one-dimensional positions problem as a functions of problem size. So and then we try to solve like a sparse eigenvalue and singular value problems, and yes, it is a complex here, so but we will try eigenvalue k. And then we also like to see the comparisons like spectrums of the lowest 25 eigenvalue of the sparse matrices as a functions. Okay, so these are the way you can try to understand. Thank you very much. I hope next class we will continue. Thank you.